Specifically, if you guys have any questions, yeah.
Are there like any example programs available on the website at all? Or online?
Yeah, actually, there are sample. If you go into Robot C, especially, I know that just because that's what we use to program. But if you go, there's actually, if you go to File, Open Sample Program, there are samples of any of the different, most of the different sensor readings or specialized functions.
Library.
Yeah, there's also Xander Soldat from Denmark creates.
How you spell that? Is it S-A-N?
Yeah. He writes libraries for a bunch of the sensors. So any of the Hi-Technic or NXT sensors, he writes the libraries for that, and he provides sample code for all of that. And I believe that actually goes out with.
It comes
Robot
with your Robot C.
Okay, Xander.
Soldat. I don't know how to spell it.
Xander is Xander
X.
X.
Yeah.
You probably have something like the turn left wheel like that as well.
Yes.
Any reason to not have just one which says turn wheel, which one?
You could do that.
Okay.
We just found, I mean, then you're adding another input. It doesn't really matter. We found just for the way, I'm the main programmer for our team, and just the way I think about it, I think, okay, I want to turn the right wheel. And so I type turn right wheel and then put a heading.
I thought maybe you tried that as well and then found, well, you were turning both of them at times, like turn right and then turn left.
We had 3 different turn routines. We had turn right wheel, which moves only the right side of the robot. Then we had a turn left wheel, which turns only the left side of the robot. And then we had a turn in place, which spun both sides. So it's really whatever you want. It's however you want to set it up.
And the neat thing is, the way they do it, it is modular, so you can just grab that piece of code and drop it into whatever routine you need.
Did you have any other source besides the Robot C and the Xander thing? And did you ever have any luck finding anything like this? That was, I'm old enough to say, give me a book. Did you guys have any luck with that? I mean, I haven't found anything. I just.
If you just if you just Google what you're trying to do, Robot C, and then whatever you're trying to do.
Yeah, but I mean, like
you'll
through someplace
find-
like Amazon or something. you
Oh,
not see
no, we
anything?
didn't go, I don't believe we found anything
Yeah, I
I
specific.
believe there's nothing like book-wise that we use, but if you ever need anything, there's always the FTC forums.
Yeah, the
On that
FTC
first website.
programming forums, that's out there for teams to ask questions.
Yeah.
There's usually a long, frequently asked Q&A, and then there's specifics that you can search for.
One more question.
Yeah.
Since you guys are experts in programming this stuff, can you multi-thread this as well?
Yes, you can. It's actually very easy to do in Robot C. The way you would do that is with tasks.
Okay.
So you just there's task
Yeah.
main, which is where you put your actual program, and then you can say task.
Task is you to submit, something like that.
Yeah, some of our main tasks are task drive manipulators. That's where we actually do all of the motor moves. For our robot, we have a task to monitor all of our sensors. So that's happening independently. We read all of our sensors and set them to variables. So we don't have to worry about if multiple things are trying to read the sensor at the same time, and that can cause problems with Robot C and have your program crash and all kinds of bad things.
And then you can probably go ahead and say, has this task completed or not?
Yeah.
So that you can join them in the end.
You can, yes. But if you want to do stuff that, like, if you want to make something that happens in a sequence, you use functions.
No, what I meant was, turn right wheel this much, move this motor up this much, but only after both of them have completed, then
yes.
do this. So I could be doing both of these in parallel, but I have to wait for
you
both
could
of them to
put-
complete to do the
You
next.
could use variables or however you want to do to sync your tasks. So you could say wait until, or have a loop checking until a variable is true.
Wait
And-
until this one's done, wait until that one's done.
Yeah.
Simple stuff.
Yeah, you can definitely do that. Yeah.
Where did you get the plastic container thing? How did you like shape it?
The plastic
Oh.
is, a lot of it's laser cut. Oh, you wanna do that?
We actually went through and all of these, they're all separate shields. So like this one's separate from this one and this one and this one. And we actually go through and we design these in, I think we used Autodesk Inventor.
So we designed all of our parts. Those were all custom made by us. So we designed them in CAD, and then we had access to a laser cutter through a machine shop near our house. And then we could just go there and cut our pieces.
So the piece he's holding right now is actually our wheel guard, this one right here, but it's unfolded flat. And that was like right out of the laser cutter. So Phil, if you want to pass it around.
Do it manufactured, you make it yourself?
Yeah, we.
Yeah.
You mentioned that the robot, that it almost sounded like there's an external control on when the robots can start and stop.
Field control system.
Field control.
Yeah, the field control system, that will be set up by the tournament. That's what they actually use to run the matches.
Okay.
And that's basically a program specifically developed for FTC. And what it does is it has your autonomous period and your teleop period, and that communicates wirelessly with all of the robots on the field. And so when you hit the go in the field control system, and that's also what you hook up all your controllers to, but when you hit go, it'll send a signal to all of the robots in that match saying autonomous has started, you can move. And then that'll actually disable your robots. It'll shut off all of your motors, and it won't turn it off, but it'll stop your programs, make sure everything's not running.
So is there a piece of code that we have to incorporate in
Yeah,
that?
that is
They
the,
provide.
They provide that
some
piece of code?
Yes.
It's all on the FIRST website. So
Okay.
yeah, that'll be your greatest resource there. usfirst.org. Go to your
yeah.
go to the FTC page, resources, and I think it's under either Samantha or Field Control System.
And it ships with C.
The piece of code comes with Robot C.
Yeah.
Okay.
You don't have to write it or anything. Yeah.
So there's another option to Robot C. Like I know you're all
There's-
about Robot C.
There's LabVIEW.
There's
It's-
LabVIEW,
it's
you can-
Icon, the picture.
Yeah.
based.
LabVIEw
I use LabVIEW.
is
That's right. Okay.
LabVIEW is much similar to NXTG.
Yes.
And so when we actually started using LabVIEW our first year, because we had just come out of FLL, and it was very easy to learn, and the transition was pretty simple. The problem we ran into with LabVIEW is that it compiles it and takes up much more space on the brick.
Right. Okay.
And we could only fit 5 or 6 autonomous routines in a single, or on the brick at one time. So a program that went from 60-ish kilobytes, taking up a large chunk of the space on that brick, went down to about 12 kilobytes when we transferred to Robot C. Now that did mean learning a new programming language and having to basically rewrite all of our code in Robot C, but the transition was worth it, and once you get it, it's just another program.
It's the difference between being able to run a few starting positions and being able to do anything from any starting position.
I get that. So like, let's think of, even though I'm in the third year, I'm gonna say I'm the first year. So first year, would it be easiest to start at least with LabVIEW, then build into Robot C?
I would kind of say no. I mean, it's the transition. If you're gonna go with viewer whatever, and if you aren't concerned about the fact that you might fill up the NXT space, LabVIEW was very easy to learn based on NXTG.
Mm-hmm.
But if you're planning on using all of the functionality of it, if you just start off learning Robot C, it saves you time. You don't have to write your programs twice. I would find that, I mean, if we were doing it over and I knew what I knew now, I wouldn't have bothered starting in Lab.
Okay.
And we're not saying LabVIEW is bad, just that we preferred Robot C. I know that National Instruments either last season or the year before, actually rewrote a lot of their code to make things more efficient.
Yeah,
after
they
it
did
compiled.
shrink it, but
But
we
we
were
s-
already in Robot C at that
And
point.
C is still smaller either way, in this case, so it's mostly personal preference, and late season is the time when you would notice it. So if you have enough time, you could relearn it, but you probably want to get things sorted out ahead of time.
And learning text-based code might seem daunting at first, but it'll really help you out I mean, if you don't already know Robot C or any programming language, it's actually kind of fun to learn. And you won't just use it on your robot. You can use, like, this is a great gateway into other programming languages you could use for anything. I think that's about all the time we have.
Just to follow up with questions about books and where you can find stuff, cs2n.org, which is put out by Carnegie Mellon, they have a 10-week course that is Robot C programming geared towards FTC teams.
Yeah.
cs2n.org.
So,
And if you guys have any more questions, there's actually going to be like some work time out in the main area. We're going to be out there wandering around. Just feel free to find one of us in the orange shirts.
dealing with traffic, you're not the only robot on the field.
In practice, you might be, if you're practicing on your own field at home. But if you get to a tournament, then there are 4 teams on a field rather than just 1.
Can I ask you something, when you talked about multiple starting locations, I'm gonna get a little too detailed, but like or dealing with traffic, so if you have sensors on there, could you actually, like when you program, you said you had 28 different programs, but like if you had sensors on there and that if somebody if they could sense something within so many, whatever.
2 years ago, there was this mountain in the middle of the field, and teams would have to climb over the mountain.
Yeah.
And teams figured out they could sense when something came over the mountain using the ultrasonics. That would be an example. You'd know how far away it was based on where you were,
Yeah.
and you could detect when they got close to you. You could also use ultrasonics to find walls. There's IR beacons. There's usually a multitude of different sensors.
So then, with that, you would use conditionals then to
You can, you don't have to, but yeah, you can for a lot of these.
In general, our routines do not. What we do in place of that is we go out and scout the other teams, so watch their runs, and we can say, especially once you start getting into later matches, okay, we've got these 3 other teams on the field. We can pretty much guess this one's going to go here, this one's going to go here, and you talk with your partner, and then so you can, if you have enough variety in your missions, you can say, we're going to run one that either doesn't interfere with any of them or purposely interferes with them if you want.
Yeah.
Now we just want to open it up to discussion if you have any specific questions. Anyone?
In a lot of other programming languages, there are libraries. When you program in this, do you have any libraries existing?
Yes, there are libraries.
Xander Soldat from Denmark has written a very nice set of Robot C libraries for all of the supported sensors. We do use his library. It does ship with the current version of Robot C. Why do you guys use Robot C, and did you always use Robot C?
So for that, no, we did not always use Robot C. We started with LabVIEW because we had just came in from FLL, and LabVIEW and NXTG were very similar. We actually switched to Robot C once our programs, specifically our autonomous program, became too big to fit on the NXT. Robot C compiles into a much smaller size. Our program went from being 60 kilobytes to 12. And if that's just an example of scale on how much of a difference. I mean, it took learning a new language, and so learning some new things, and we had a point where we were basically rewriting all of our code in Robot C. But it gave us the option to have 28 autonomous routines.
What did you run into with the lab view there? How many autonomous routines did you have?
10 maybe?
I think more like 3 or 4, but
Was that it?
it might have been 5 or 6.
It was a pretty small number compared to what we got to with C.
Yeah. So we had a bunch of options for every one of our starting locations. We could do basically anything that would score us points in autonomous. So we wanted that option, but we couldn't get it with LabVIEW, so that's why we switched to Robot C.
Do you guys know what language other teams are using?
Most teams do, I believe, use Robot C.
A few use LabVIEW.
I would say as you move up the competition, by the time you get to World Festival, 80 to 90% of the teams are using Robot C. You'll see LabVIEW more like we did as you're getting started, but most people have run into the same roadblocks we did.
One of the perks of Robot C is you can actually run your robot from Robot C. So you don't have to start up FCS to test the robot. You can try driving, make sure your code works right from Robot C. And then I'd just like to emphasize clean code again. At the start of this season, I think we spent like a week, or Joey spent a week cleaning the code, just making it so that everything was understandable and all of the different functions had names that made sense and were easy to think of. And it actually, we noticed a drop in like number of random failures.
Yeah, we were having this problem, and this was actually more in Teleop, but the same principle applies there. We would have this problem where our arm would move a routine twice. And we actually found out because we had errors that were just caused by code that we didn't realize we hadn't deleted, kind of thing. And we found, oh wait, we're actually calling this in different places, and it was giving us problems.
As their coach, one of the things I noticed they liked to do was if they had code that they wanted to delete, they would comment it out in case they needed it later. That ended up being the source of a lot of these kinds of errors. And actually versioning your code and really deleting it so you could go back to an old version if you need to see it, but it's completely gone from the current version, ended up making things much cleaner, didn't it, boys?
Yeah.
And also with the clean code, that sort of fits in with the spend time to save time. Because it might take you a little bit longer when you're actually programming. It might take you 10% longer to actually put in the comments, put in the spacing, put in the indentation. But if you're going back later to edit the same part that you wrote a month ago and you don't remember exactly how it works, trying to refigure it out without those comments, or if it's spaced weird so it looks like things aren't where they actually are, and then if you're looking for something and it's not where it should be, if you spend that 10% of time to make it clean code in the first place, it'll be worth it later.
So what kind of comments might you have at the very beginning of each of your autonomous missions, and where else do you put that same documentation?
In our code in Robot C, above every single autonomous mission is the number of the mission, and then also a detailed description of what it does, including where it starts, where it goes, and what field elements it changes. And this is in 2 different places. This is in the code, but we also have a Google document that we've went and typed all of these again so that we can, I think it's actually up right there. Yeah. So we can, on the field, we'll print that out and we'll bring it with us.
It's our autonomous mission playbook. So the field coach and the drive team discuss ahead of time based on what our scouting we've seen, what we're going to do on the field to decide how to counteract whatever the other team's doing or whatever we need to get done on the field. So you could do things this year, like you could knock over a specific crate stack to be ready to pick it up. You could plow down the field. You could block your opponent. You could get a bowling ball. And you could know ahead of time what number I choose, what I'm capable of doing, and how I can use that on the field to my advantage.
It's a lot better than memorizing 28 autonomous runs.
Yeah. Especially when some of them are really complex and others are drive straight.
So did you guys say eventually you convert to a versioning system? And
Yes.
What version tool do you use?
We don't actually use a tool. What we do is when we name our programs, we have autonomous 4251
Our team number.
and then dash whatever number it is. So we on our first version it's auto 4251-1, and then we get it to a runnable state, and then if we want to change it, we save it as auto 4251-2. And so if we made a change and suddenly our program doesn't work, we still have the first version there that we can just go back and say, oops, this one didn't work, go back to the first version, it still works.
You just started using header files last year. What did they do for you?
Okay, yeah, this is more specific to Robot C, but you can have what are called header files, which are basically just files of program code that you can save on the NXT for use by your main autonomous program. What we had was we actually had 2 of those robots near the end of the season, and there were slight differences just because you can't build them exactly the same. And we had our angle sensor on the arm was calibrated differently between the robots. So one on vertical was 280 degrees, and the other one was 90. And so what we did was we had a header file for each robot. So we could say, we're running this robot, include this header file with this set of variables specifically to this robot.
What time does this session run through?
10:40 or
Okay.
11:40.
So you guys have about 5 more minutes of questions.
Does anyone? Yeah.
Are you guys, did you try and use the table in virtual worlds? Or did you try that?
We didn't.
Physical results on the field, emphasizing again, you want to have a field accessible to the user. Knowing exactly how your robot's going to perform is a really good thing to know ahead of time, because you can time how long specific runs take, and a lot of defensive runs at least depend on how long they take to complete. So if you have to be at a certain point on the field, you need to know how fast your robot can get there, knocking down everything in its way, moving, driving, turning. You need to know all that time ahead of time. And I think that seeing it physically and being able to time it repeatedly back to back is very, very good at getting you reliable.
Another thing I just thought of, one of the really big things about autonomous is making sure your robot starts in the right place.
Yeah.
Because that's the position the robot goes off of for the entire autonomous run. So if that's a little off, then your robot will be a little off the entire autonomous run, and it might not do what you want it to do. So sometimes it helps to have the actual field, because then you can have your team get used to resetting the robot every single time to test. And it seems really annoying at first, but once you get to the actual game, you can go up to the field and you can set your robot perfectly like that. And it'll help a lot in making sure your autonomous runs right.
For example, for what he's saying, this year we were setting up on those red and blue platforms. We knew for our run exactly how far the robot should be from the edge of that platform. And we also knew that it should be square against the wall. So the wall is your friend when you're setting your robot. If you can put either your back wheels or whatever farthest part sticks off the back of your robot against that wall flat,
You know you're square.
you know you're always going to be pointing very, very close to in the same direction every single time.
What's the most valuable sensor you found for autonomous for you guys?
The gyroscope.
The gyro lets you turn very, very accurately and consistently when you get going. You should explain why.
Alright, so the gyroscope, what it does is it will put out how fast you are turning. and in what direction. So what you can do with that is if you do a little bit of math inside the program, you can calculate what direction you're facing. It's similar, you can basically get the same output as the compass sensor, but the compass sensor doesn't really work very well in an FTC setting just because there's so much metal and interference. So the gyroscope, you can use that to calculate your heading, and that's what I was talking about with that reusable routine. When I said put in a heading, we could say turn and point in this direction. And no matter what direction the robot was pointed in before, it would turn itself to face the direction we want it to go.
Why is that better than using odometry to get to that direction?
If your wheels get caught on top of, for example, a racquetball that might be on your field, like this year's field or the last year's field, you might have one side of your wheels in the air, and if they spin for half the turn, you might turn half as much as you wanted it to, and then you're going in a direction you didn't plan on.
Another nice thing is that near the end, no, I think it was actually near the middle, when we were having trouble with racquetballs, we actually found out what you can do is the gyroscope can sense if your wheels are moving and you're not turning, and then you can do a programmatical fix. We found if you rotated the wheels a certain way, we could get a ball out from under the wheels.